Hello and welcome to this YouTube presentation on speculation and success. My name is Charles Victor and I'm the Principal Consultant for Repose Pty Limited. In this presentation I'll show how the success or failure of projects that lead to the automation of business requirements depend on senior management decisions to proceed with them, and that their decisions are based on the speculations of their advisors. I'll show how these decisions can be based on predicate logic and especially the use of a simple truth table. I'll also demonstrate through the use of two truth tables how business requirements and IT can be fully aligned. In business and indeed in life, everyone speculates. That is all part of being human. So what is speculation? Using the Concise Oxford Dictionary, I discovered the following definition, quote, "To form a theory or conjecture, especially without a firm factual basis, or to meditate, or to gamble recklessly," unquote. Using the Oxford Thesaurus, I uncovered the following synonyms: conceive, divine, dream, fantasize, guess, or imagine. Now, without full knowledge of the entire business, management, operatives, and their advisors need to either uncover the meaning behind the business and/or speculate as to what they believe the business is supposed to or ought to be. The truth has a great deal to do with whether the outcome of such a speculation will assist the business to succeed or fail, but more on this later. As someone once stated, the first casualty of war is truth. And running a business is a bit like fighting a war. Plenty of objectives, targets, allies, and opponents. So what is a truth table? According to the Wikipedia, it is a, quote, mathematical table used in logic, specifically in connection with Boolean algebra, Boolean functions, and propositional calculus, unquote. And truth? According to the Concise Oxford Dictionary, truth is something that is, quote, in accordance with fact or reality, unquote. Putting the two together, we have two examples of a truth table. The first example is a truth table with one proposition. The proposition is in the first column and the truth factor in columns A and B. If the proposition is correct, then the truth factor in column A is yes, and therefore the decision is to continue. However, as the truth factor for column B is no, the decision is not to continue. The second example is a truth table with two propositions. Is person 1 correct and/or is person 2 correct? Column A represents the fact that both people are correct and therefore the decision is to continue. However, if one or both people are incorrect, then the decision is not to continue. Truth tables are useful up to a point. The more propositions there are, the more columns. The number of columns depend upon the number of outcomes raised to the power of the number of columns. In the first example, the number of propositions is 1, and therefore the number of columns are 2, either yes or no. 2 propositions give rise to 4 columns, 2 raised to the power 2, and 3 propositions lead to 8 columns, or 2 raised to the power 3, and 4 outcomes have 16 columns, or 2 raised to the power 4, etc. Before demonstrating the use of truth tables, I will need to identify the people involved in the proposition column. In order to make a sound decision, knowledge is required. As not every manager is capable of having all the knowledge of the business, they are beholden to either employing advisors or outsourcing to a supplier who have the advisors, both non-technical and technical. These people need the expertise to uncover the collective knowledge of all business operatives and/or sift through all available information and turn it into useful knowledge. The advisors utilize frameworks or techniques which assist them to systematically uncover the knowledge and feed this knowledge back to management, who are then able to make decisions to continue with the projects or not. These non-technical advisors are called, for better or for worse, enterprise architects, or EA for short. Once the decision is made to continue with the project, the responsibility is passed on to the technical advisors, who have the expertise to turn the collective knowledge into a reality which will ensure or enable the business to succeed, either thrive or survive. However, as most advisors do not themselves have an in-depth knowledge of the business, they need to speculate as to what the business operatives are talking about. This speculation can turn out to be either true or false, depending on how well they use the tools at their disposal, in this case, the framework, thus opening the door to the likelihood of failure. I will now proceed to use the truth table to demonstrate the effectiveness of the speculative column of the enterprise architect, followed by a truth table demonstrating the likely outcome of the project once the technical advisors have completed their designs based on the knowledge acquired from the enterprise architect or architects. For more details on the business operatives, please see the YouTube presentation on the stakeholder. In this truth table, you'll notice that there are 3 rows in the role speculation column. Hence, there will be 8 possible truth factors, column A through H. Column A represents that the speculations reached by the enterprise architects, i.e. a person or persons performing the role of the business analyst, knowledge architect and strategists, are all correct, and that the outcome is to continue to the next phase. In the case of columns B and C, where one of the 3 may speculate incorrectly, the decision is to continue. However, the decision is now based on politics rather than science, and depends on who has the most influence with the decision makers. In the case of column D, even though 2 roles speculate incorrectly, the decision may go ahead on political grounds, if and only if the business analyst is the major influencing factor. In the case of column E, the decision could go either way, depending on who has the most influence. In the case of columns F through H, the decision should be not to continue. However, senior management could override and push ahead. Once management decides to continue with the project or projects, the success or failure of said projects depend upon the speculations of 2 additional technical architects, namely the data modeler and the database designer. This truth table shows that the projects have a high success rate if all 3 roles speculate correctly, column A, or in the case of column E, where the enterprise architect speculates incorrectly, however the 2 technical architects speculate correctly, lucky guess. In all other cases, B through D and F through H, the chances of success are near to impossible and could depend on pure luck. In the case of column A, business and IT are fully aligned, only partially aligned in columns B through D and unaligned in columns E through H. The reasons why projects will fail are columns B and F, correct facts but poor database design, columns C and G, incorrect facts but a good database design, columns D and H, incorrect facts and poor database design. In closing, aligning business requirements and IT depends on the correct speculations of the various roles of the advisors, or in this case the information architects. Get all the speculations right and the alignment is easily achieved. Get 1 or more speculations wrong and the alignment will never be achieved. I would like to thank you for viewing this presentation. The PDF is available for a small fee should you want to assist us further the aims of repose.com and especially repose.org. You can find the aims of repose.org on www.repose.org. You can reach me by sending an email to charles.richter@repose.com. Once again, thank you for your attention.